math educator. In this video, I want to take you through the journey of the development of mathematics in ancient India. And the reason I made this video is because there's a big difference between the mathematics that is being taught today as Vedic mathematics and the actual mathematics that was done by the ancient Indian mathematicians during the Vedic period. This video is my attempt to give you a true picture of what Vedic mathematics actually was and is. The history of mathematics in ancient India can be traced all the way back to the Indus Valley civilization around the year 3500 BC. Archaeological evidences unearthed from excavations at Harappa, Mohenjo-daro, and other sites of the Indus Valley civilization have uncovered clear evidence of the practical usage of mathematics. For example, most of the bricks used in the Indus Valley civilization for constructions were in the proportion 4:2:1. They also used standardized system of weights based on the ratios 1/20, 1/10, 1/5, 1/2, 1, 2, 5, 10, and so on, with their unit weight approximately equal to 28 grams. These standard weights were mass-produced in various geometrical shapes such as cylinder, cones, tetrahedron, and hexahedra, which demonstrated that the people of the Indus Valley civilization had knowledge about three-dimensional geometry. The people of the Indus Valley civilization standardized their unit of measurement of length to a very high degree of precision. They designed a ruler, which is known as the Mohenjo-daro ruler now, with a unit of length which was approximately equal to 1.32 inches or 3.4 centimeters. This ruler was divided into 10 equal parts, so perhaps that's where the origin of the decimal system lies. Further excavations carried out in the port city of Lothal demonstrated that the people in the Indus Valley civilization knew how to measure the position of stars in the sky and use them for navigation. By modern standards, this practical usage of mathematics might seem very elementary to us, but back in the day, these were the state of the art as far as science and technology and mathematics was concerned. After the Indus Valley civilization, the next era of Indian mathematics was the Vedic age. The Vedic age lasted between the 9th century and the 4th century BC. This is the period where the first identifiable mathematicians, or rather ancient scholars, appeared on the scene. Several textbooks which survived from the Vedic age gives us a glimpse into the early world of mathematics. What we know today is that back then, most of the mathematicians or scholars were interested in mathematics for one primary purpose, and that was to create sacrificial altars with the perfect measurement. The most important religious textbook of this period was the Sulba Sutra. The Sulba Sutra contains instructions on how to construct a perfect sacrificial altar, or the yagna. The requirements for the fire altars were so specific that some of them could be challenging even for a modern-day mathematician. For example, one of the specific requirements of the Sulba Sutra was that all fire altars must have the same area but different shapes. This, we know, is not possible for many shapes such as a square and a circle, because this would require us to square a circle or circle a square, and we know that both these constructions are not possible because of the impossibility of constructing a transcendental number. Among the earliest and the most important mathematician of the Vedic age was Bodhyana. Bodhyana lived in the 8th century BC, and he is the composer of the Bodhyana Sulba Sutra. This sutra contains, among other things, an approximation formula for the value of the square root of 2, which is accurate to 5 decimal places. Among many other things, the Sulba Sutra also contains the first known verbal expression of the Pythagoras theorem. It states that the diagonal of a rectangle produces an area which both its length and breadth produce together. In addition to the Bodhyana Sulba Sutra, there were two other Sulba Sutras. The next Sulba Sutra was composed by Manava and is known as the Manava Sulba Sutra. Manava lived between 750 to 650 BC. The third and the final Sulba Sutra is known as the Apastam Sulba Sutra, which was composed by Apastam, an ancient scholar who lived in the 6th century BC. The religious textbooks also provide evidence of the usage of very large numbers. For example, there is a prayer or mantra which is used during the Ashwamedh Yagna, which uses numbers all the way from 100 to 10 to the power 12. A very important landmark of the mathematics of the Vedic period was the work of the Sanskrit grammar scholar Panini. Panini lived between 520 BC to 460 BC. His work primarily touches upon the areas of Boolean logic, the null operator, and pioneering work in the field of context-free grammar, which is a set of rules to describe all possible strings in a formal language. Panini's concept of context-free grammar has found applications in modern-day computer programming. The three Sulba Sutras of Bodhyana, Manav, and Apastam, along with the work of Panini, encompasses the body of mathematical knowledge that was known during the Vedic age. The year 400 BC marks the end of the Vedic, or the earliest period of Indian mathematics. The next great period started in the year 600 AD. However, between these two periods, there are prominent mathematician and mathematical concepts that were developed and are worth mentioning. Among the prominent mathematicians in this intermediate period was a mathematician by the name Pingala, who lived in the 3rd century BC. Pingala was a music theorist, and during his work on the enumeration of syllabic combinations, he stumbled upon what we now call the binomial coefficients and the Pascal triangle. Although he did not know the complete binomial theorem, Pingala pioneered the concepts of combinatorics and binary number systems. His work also contained the Fibonacci numbers, which he termed as Matrameru. The history of Indian mathematics would be incomplete without mentioning the contribution of the Jain mathematicians. The most significant contribution of the Jain mathematician was their success in liberating mathematics from its religious constraint of the past and making it into an independent discipline of its own right. It was the Jain mathematicians who introduced us to the concept of infinity, and they introduced not only one infinity but the concept of multiple infinities. Not satisfied with a single infinity, the Jain mathematician introduced 5 different forms of infinities. These were infinity in one direction, infinity in 2 directions, infinity across area, infinity everywhere, and infinity across time. Now, if we look into these concepts of multiple infinities, the first 2 form, infinities in one direction and infinity in 2 direction, they refer to infinity along a straight line, that is a single dimension. The third form of infinity, which is infinity in area, it refers to infinity in 2 dimension. And the fourth form, perpetual infinity, it refers to infinity in the time dimension. Thus, with these 5 forms of infinities, the Jain mathematicians have covered the concept of infinity across space and time. The Jain mathematicians are also credited as being the first to use the word shunya to refer to void or nothingness, which is equivalent to the concept of zero. They devised notations for exponents such as squares and cubes in order to work with Bijganit Samikaran, which we now call algebraic equations. The most important work of the Jain mathematicians was the Surya Prajnapati. Another important work was the Satnanga Sutra. Among the prominent mathematicians of this era was Acharya Bhadrabahu. He was the spiritual teacher of Chandragupta Maurya, the founder of the Maurya dynasty. Before we move on to the classical period of Indian mathematics, we need to talk about the Pakshali manuscript. This manuscript was written on birch barks, and 70 of its leaves survive to this day. The exact age of this manuscript is not known. Radiocarbon dating from different sources have put an age of this manuscript somewhere between the 2nd to the 9th century AD. This manuscript was a compendium of the known mathematics of the era. It contained the rules of arithmetic, including fractions, square root, profit and loss, simple interest, algebraic contents such as simultaneous linear equations, quadratic equations, arithmetic progressions, and problems on geometry, including the volumes of regular solids. The Pakshali manuscript is most famous for a little symbol that it contained. It was called Shunya Bindu by the ancient Indian mathematician. The word Bindu means a dot, and the symbol was represented by a dot. This symbol would travel through the hands of the Arab merchants to Europe and the rest of the world and revolutionize the world of mathematics as we know it. Today, we know this symbol as the zero. From the geometries of Bodhyana to the concept of multiple infinities of the Jain mathematicians, mathematics in India had progressed a lot since the Vedic ages. However, the greatest period of Indian mathematics lies ahead. This is the classical period, which is also known as the golden period of Indian mathematics. And in this period, legendary mathematicians such as Aryabhat, Brahmagupta, Madhavacharya, Bhaskaracharya, and Nilkant would take